Great. Hello again, everyone. So we're going to be talking about ZONE3. So ZONE3 is OGP software that's running all of the smart scopes in this room here. So how many people here are ZONE3 users already? Can you raise your hand? Okay. So I have a little bit at the end of the presentation that might be a little too detailed if you're not using ZONE3, but it's about what's coming next and what the latest enhancements are. We'll get started. So what is ZONE3? It's a 3D CAD-based multi-sensor metrology software. We also offer a software package on our smart scopes known as MeasureX. Some of you may have MeasureX. This is not a full 3D package. It's more for 2D, what we call 2.5D applications, and it doesn't support all of OGP sensors. But ZONE3 is our primary package that supports all the sensors we make. So it's CAD-based, meaning a lot of the tools and a lot of the unique features of ZONE3 require a CAD model to use, but you don't need a CAD model to use ZONE3. You can program with a 2D CAD model, you can program with no CAD model. The software is for any application, but it's primarily its unique features are related to CAD. And it runs our machines and evaluates the data. So you use ZONE3 to acquire the points and also do the analysis to get your measurement results. So we say ZONE3 is the most comprehensive metrology software. And what does that mean? We support many types of sensors, many types of users, and there's many ways to save time. So we're going to go through each of these aspects and show why ZONE3 is the most comprehensive software. So all of the sensors we talked about earlier, the video sensor with image processing, the lasers through the lens lasers and off-axis range sensors, touch probes, tactile probes, and scanning probes, they're all supported in ZONE3. But the important part is the workflow is the same regardless of which type of sensor you're using. So whether it's video, laser, or touch probe, you go through the same steps. You navigate around the CAD model the same way. We have something called path generation to generate the measurement binders and the points for you automatically. It's the same process regardless of what sensor you're using. So we're going to show a little video on this. So I get it to go. So first is the video sensor. This goes kind of quick, but I'm clicking around the CAD model and it's moving around the part. I don't know if you can see it on where I'm clicking. And if I want to measure a feature, I click it in the CAD model. So here I'm measuring the profile on the outside of the part. And then I click this path generation button to say, software, you pick, you do it automatically. And the path, meaning the finder, where to measure on the part automatically gets generated. So now we'll switch over to probe. It's the same thing. So here I'm going to click points on the CAD model for where I want the probe to take points. And over in the image window, since we're using a probe that's off-axis, you're actually seeing a simulated video image of where on the part the probe's over, so you can drive around easily. So again, if I want to use my path generation function, I can click there and it will automatically create the path for me as opposed to manually clicking on the CAD model where I want to measure. So I think I do that now. Yep. So if you're using a different tool, meaning video versus probe, there's different settings in this path generation window, because obviously the sensors have different capabilities. But again, the workflow is the same. So here I'm changing how many sections or I want to scan on the cylinder. And now I'm switching over to a laser tool, and this is a through the lens laser. So the video image is actually useful here because it's where the laser is going to scan. So again, I'm going to do laser focus points on the top of the plane, and I can just click on the CAD model where I want to take those focus points. Or I can use the path generation functionality here too. So with a laser, you can either take focus individual points for one measurement, or you can take a scan. So here I'm just clicking a little path on the CAD model and saying, tell the laser to follow that path. So the point here is once you know how to use one type of sensor, you can use Zone 3 for the other types of sensors. Either if you buy them later, add them onto the machine, or if you're just training a new user, the workflow is always the same. The next feature of Zone 3 is that we have workflows for many different types of users. So meaning operators, the person who's just in charge of running the program. Programmers, the person who has to tell the machine, teach the machine how to measure. Or the engineer that's taking the results from the measuring machine, deciding what to do about it. Change the process or pass fail. In some companies, all of these users are the same person. In other companies, we have different users depending on their needs. So for operators, the person who's just running the machine, we have many tools to make it easier. So we have this user interface called Launchpad. It's a picture at the top of the screen where you can run routine by just clicking on a picture of it. You can also pop up videos on how to set up the part or instructions. You can have it read to the operator on what to do. And again, this is meant to be as easy as possible so no one has to pick which routine to run or manually set up the part. And the screen where you see the different parts in the big, large field of view, and some of them are red and some of them are green. That's a function we have called Auto ID. So this works very well for either stamped parts or mainly 2D parts, where you can put them in the field of view, but they can actually even be bigger than the field of view, and the software will go around and trace the outside, and by the outside, it will pick the routine to run. So the part's already been programmed, and the software will use the image to recognize which program to run that program, and then turn the part green or red if it passed or failed, essentially. And the bottom picture, I'll show a video on this, is something we call feature extractor. So if a user wants to walk up and measure something that doesn't have a program, they don't really know how to use the software, it's a tool that automatically pops up measurements for you. And I'll show a video on that. And this one has sound, so hopefully it works, we'll see.
The feature extractor tool allows Zone 3 to automatically identify and extract features within the visible field of view without any pre-programming necessary. Simply click the feature extractor button in the Getting Started ribbon group, and the geometry of the part is extracted with the results shown right on the screen. Results can automatically be generated to see additional attributes for these extracted features. The types of features to be extracted can be configured in the Feature Extractor Properties window. In this example, I have just circles, arcs, lines, and widths. To turn these extracted features into steps in a program, I can click the Add Steps button. In this case, I will extract everything, and automatically those features are turned into steps in my routines tree. To quickly construct other features out of these extracted components, I can select one and then hover over an additional one, and on the screen, available constructions are automatically shown. Double-clicking will add automatically to the program. In this case, between these two circles, I can see a distance min, and a distance max, and choose the one I want to add to my program. For parts larger than the field of view, I can extract across multiple images. Extract once, select a feature, and now when moving the stage, I can right-click and refresh to extract again. And when hovering over that secondary feature, I can now get the overall width of the part across multiple fields of view. Extracting across multiple fields of view can also be done automatically. An area scan allows you to configure a known region of the machine stage to extract features from. A stage scan will cover the entire measurable area and extract all features that can be seen. If using Feature Extractor for programming, once you select a feature, you can enter in nominal information before adding steps, so that it doesn't have to be done afterwards. To obtain position information from extracted features, the coordinate system can be aligned to an extracted feature. Simply click a feature and zero that out in the DRO. Now, when reporting additional features, the location is based on the origin, which is aligned to the extracted feature. Orientation of the origin can also be controlled through the DRO. This allows a coordinate system to be set up through multiple extracted features. The feature extractor.
So we originally made that tool for our large field of view systems that had that 100mm field of view. But since then, we've enhanced it to handle the multiple field of views like you saw in the video and actually scan the stage. So people using smart scopes have started using it as well, and it's been very helpful for programming. So the next type of user that ZONE3 is good for is the actual programmer. Again, the person teaching the machine how to measure the part. And what's great about ZONE3 is we have something we refer to it as visual validation. So first you have a model of your machine and your part is shown in the model windows, I'm sure you'll see around the room. But once you start programming and say you start constraining your coordinate system, the origin actually dances around. You'll see which axes aren't constrained. And the same thing if you're doing GD&T with different coordinate systems or different datum structures, you'll see how the part can move and still pass. So it's very, we call it visual validation. It's very easy for the programmer to see what they're doing. We have a user forum called zone3.zone, and a lot of our employees and our customers are very active. So this is a great way to, if you have a problem with ZONE3, to get very quick help, or to search the database if you need any assistance. And the other thing we have in ZONE3 is a MeasureMind routine translator. So MeasureMind is our legacy 3D software that we use for 20 years on smart scopes. It's still available today if you want to purchase it, but we're not enhancing it at all, and it's not available on any of our new systems like SP because the new technology isn't supported. But you can take your existing MeasureMind routines and import them into ZONE3 and they'll translate them into ZONE3 routines. And the last user for ZONE3 are engineers. Meaning there's many tools to evaluate the measurement data and try to figure out what you should do about it. You need to talk to manufacturing, you need to talk to the design engineers. So we have graphic reporting. You can see the CAD model, you can see flyouts on your model of what the tolerances are. You can actually see, I know it's probably too hard to see, but you can see like the results graphically. You can see whisker plots, 3D color maps. And the third thing that ZONE3 is very good at is efficiency, saving time for the operators or the programmers or the engineers. So we're going to talk about some video tools that allow you to measure faster and get more parts out. The first is parallel processing, where the machine will take one snapshot and measure everything at once that's been programmed, as opposed to some of our legacy software or other competitors' software that takes a different camera frame for each feature. The second feature we're going to talk about is called Optimize, where say you either imported a routine from MeasureMind that didn't have this parallel processing, or the person who wrote the routine didn't do it in the quickest manner, the Optimize tool will actually rearrange all your binders so that your runtime is minimized. And the last thing we're going to show is called Video Aligned to CAD. So when you're programming from CAD, you have to tell the software how your CAD model is oriented relative to your part, your real part on the stage. And this can be done automatically with 2D and 3D with the video tool. Essentially, it traces around your part and aligns the CAD model automatically. I'm going to show a couple of videos on this. These ones are shorter, so good. So this one first is on parallel processing and Optimize.
Large field of view systems are ideal to take advantage of Zone 3's parallel processing capability. This allows Zone 3 to measure as many features as can be seen at once within the field of view. In this example, I will want to measure all of these slots at the same time. With one measured, I can copy this step, choose polar copy, and select the center circle, which has previously been measured, to copy about. Now I can enter in the number of copies and the angle offset. I will want to be sure to check the button to copy within the field of view. Without this, Zone 3 will automatically center each feature instead of leaving it in the same stage position to parallel process. When executing, you can see how all the slots were measured at the same time rather than individually one by one. Zone 3 on large field of view systems allows parts like this with many features that can be seen at once with the same lighting to be measured very quickly. When programming, it is a best practice to measure as many features as can be seen in the field of view at once without moving the stage or changing the light if not needed. In this example, this part has been poorly programmed with many stage moves for each feature to be measured. Zone 3 Pro provides the Optimize tool, which will automatically adjust steps to minimize stage movement. Here, you can choose to optimize, and now when playing the program, because all these features can be seen in the field of view, they're all measured simultaneously.
So again, this was shown on a large field of view system, but the same tools are just as effective on any kind of smart scope thing. And here we're going to show that video aligned to CAD functionality I was talking about. This is shown on a 2D part, but the same functionality actually works in 3D, where the software like squishes down the 3D model and somehow finds the alignment. So it's pretty nice.
When programming from 2D CAD, Zone 3 offers many tools for ease of use. When importing a DXF model of this part, the material direction is automatically determined and shown by crosshatchings in the model window. These can optionally be flipped for the whole model or individual entities. To automatically align the part to the CAD model without any programming or manual setup, the patented Reposition via Video tool will compare a trace of the actual part to the CAD model and automatically align it. This allows you to immediately begin programming off the CAD model without any setup needed. Now that my 2D CAD model is aligned to the part, I can select the Generate Steps button from the Getting Started group to automatically generate features based on the CAD model. Lines, circles, slots, and curves can be generated from the CAD either from default templates or custom-made templates which can be set up ahead of time. In this case, I will use automatic templates for lines, circles, and slots. Different optimized options exist to automatically reduce stage movement when generating the steps to parallel process. When hitting Generate Steps, in this case I haven't selected any feature individually, so it'll generate steps for the entire CAD model. Now, when selecting Done, I can run my program and the entire part is measured at once.
So that's it on efficiency for Zone 3. And now we have a couple minutes left, so I'm going to cover some of the latest enhancements in Zone 3 version 14. That's our latest version available for customers. And the first major enhancement is what we call a recur step. So this was designed for circuit boards or stamped parts where we have many of the same exact feature and you want to measure them all. So before you'd have to program them each individually or copy it, the recur step made programming them very easy. And when it's running a recur step, you actually get a status report of how many passed, failed. You get statistics automatically, and it's a very good visual indication. So I have a video on this, but it's kind of long, so I might see if I can skip through to the important parts. Probably can't do that. Well, I can show you the video here, so you can recur step. But again, it's designed for circuit boards and repeated features. The other major enhancement in Zone 3.14 was for more programming efficiency. So we made it so, this image right here, I don't know if you can see my cursor, but that path gen functionality to automatically generate your finders is now available from the model window. So before you had to open a step and click, now you can just click the feature in the model window, right click and say path gen. And it'll use the exact same settings you used last time, or give you the option to change the settings. So again, it's just for faster programming. Again, if you don't use ZONE3 already, this isn't going to mean much to you, but we added the ability to resolve and substitute between different tactile sensor types. So you could always change your style eye, but now you can switch from a scanning probe to a touch probe, or a touch probe to a feather probe, or a resonance space probe. It's now all done in ZONE3. And also you have the ability to see safe zones now configured in ICE. This is just an awareness enhancement. ICE is our calibration software we use, and you used to be able to set up safe zones, but ZONE3 didn't necessarily communicate well what they were. So what it shows you a little box around whatever you don't want the machine to drive into, say a change rack, you want to make sure the machine never drives into there. And the last set of enhancements in 14 were for routine editing. And honestly, most of these were things that we had in MeasureMind that never made it into ZONE3. The people that use ZONE3 don't miss them, but people like me who grew up using MeasureMind find these things very, very useful. So the first is you can easily change units from your digital readout. You change your angular units or millimeters to English units. You have inline editing from your results browser, meaning you can easily change your tolerances or your nominals without having to open a step and open the properties window. Save time. And you also can have step numbers now. So the way, by default, ZONE3 labels its steps by the kind of feature you're making, and then by its name, by its number. But in our legacy software packages, you always had a step number, so 1 through whatever. So now we mimic that functionality because a lot of our, again, legacy customers were used to step numbers. And that's it on ZONE3. Does anyone have any questions? Sure.
Did you want to use the mic?
Oh, yes, thank you.
Testing.
Is it possible with ZONE3 to have a fixture set up which you reference up once and then you load the part into the fixture and recheck it?
Yes.
Because we're using MeasureX at the moment.
Okay.
Okay.
Yes, that is possible.
That is possible?
Yes.
Thank you.
And MeasureX is still going to be supported. That software is not going away. We still have a lot of users worldwide. It's just not as capable.
Any more questions for Colby?
And again, ZONE3 is running on all the machines, and our team here will be happy to help you.
Okay. Colby, thank you very much. That's brilliant. Round of applause for Colby, guys. Thank you.